Welcome join today's session. So today we will talk about the enterprise AI infrastructures. So maybe in the beginning, maybe I can briefly introduce myself. So I joined ByteDance at 1915. So I worked for more than 8 years here. So during these years, I worked both on uh, infrastructures or various products. And recently, I moved to the machine learning engineers roles. So today we are talking about the AI infrastructures. So this is my understanding of the infrastructure, why it's important, and what is included, what it means to be working on the AI infrastructures. So yeah, maybe next slides. So I think during these years, we can see that AI is everywhere in our daily life. So it's used in every areas, including the language processing or the audio or video processing. So it becomes more and more important in our daily life. And so when we talk about the AIs, so these models that do the like the CV task or the language processing tasks, they are very important. But in the background, there's an infrastructure to support these kind of models to serve the users. So today's session, we mostly focus on the infrastructures that support these AI models, especially in an enterprise level, such as the scope of a TikTok, like this kind of applications. Yeah. Next slide. So first of all, we can take a look about the brief history of AI. So actually, AI is not a new idea. So in the very early age, so computer scientists, they are talking about electronic brains. And also after many years of discussions and also involvement, as you can see in the 1990s, the MLP. So I think it's a very famous term if you are merging in AI or computer science. So MLP is invented, and people are trying to use back propagation in the computations. And in after the year 2000, the DNN is invented, and the AI is become much more popular in our in all the areas of the people's daily work. So yeah, next slide. But what make it well known to many other normal peoples, not only the computer scientists or computer workers, they are because of LLM, especially the ChatGPT these years. So, and before that, I think many of you also heard about the like AlphaGo or AlphaFold and many other technologies that based on the technology or the terms that we mentioned before. So, but the question, when we, I mean, as an engineers, when we heard of these terms or when we see these kind of applications, what we want to ask ourselves is how this happened, right? Why, how should we do it? And what support the development of these kind of works? So yeah, next slides. So from my side, I think there are mainly two reasons here. So the first one is because of the data explosion. As you can see, the data, we can collect more and more data in our works here. So in the beginning, people can only use pen or paper to write articles, and there's not so much data to be collected. And during these years, we have the World Wide Web. web to generate the data and serve all the data to all the users. And the computers also generate many logs. And all of these data enable us to do more analysis of users' behaviors. And the data, it alone can't work. So in the beginning, for the traditional machine learning tasks, even if we feed with them a lot of data, they can't improve along with the data size. But after we invent the deep neural networks, the DNNs, so as we get more data, we find out that the model becomes more valuable to the users. So that's also the reason why these years we can see this, we make much more progress in the AI industry. Next one. The second reason is, as you can see, previously most people or most computer scientists, they are focused on the CPU architectures. So most of the workloads, we are based on the CPU. But during these years, GPU become more and more important because they can provide much more, they can take much more computation workloads and make, which support the AI to improve themselves. So from our side, we think the GPU will be the new CPU, and many of the workloads will be migrated to GPU in the long run. So maybe in the future, you will see that GPU will be the main part of a computer, and especially in the server side. So GPU will provide much more ability to our programs, and many of the programs will be rewrite to use the GPU as the main computation engines there. Next slide. So just now we talked about the brief in history of AI, and also why AI make much progress these years. So like the data explosion and the GPU's development. So next we will talk about what it means for us to solve the problems in the AI infrastructures domain. Next slide. Yeah. So so as you can see, in the traditional software, we have a server, and then maybe we have a piece of softwares or web browsers there, and we have our desktop application. So that's how we use the traditional softwares. And maybe in the last 10 or 20 years, cloud computing become very famous. So companies like AWS or Azure or Google Cloud, they make a lot of money because of the cloud computing. So in these areas, they use the IaaS layer or PaaS layer and the SaaS layer to develop the whole ecosystems and make a lot of companies easily to set up their own servers and to support their own business. And in the machine learning age, which is now, I think many things will be changed again. So at the so in the low level, so most of the CPU in the cloud computing servers, they will be replaced with GPU. So as you can see, many companies, they are trying to set up GPU clusters or GPU data centers, trying to build more and more to support the future development of the large language models. So in the model layer, the foundation model will be support all other applications, and based on the foundation model, maybe some companies, they will fine-tune these models and build their own small models to achieve some specific goals. And based on that, so AI applications will be integrated with most of the consumers' devices. like your cell phones or your computers, and maybe there will be new devices come out because of the AI enable them to develop new products, especially like the robots, right? So in the future, maybe our devices will be totally different from what we are using now. Um, so we believe that in the machine learning age, most of the applications will be rewrite using the AI capabilities. And many of the interactions between users and the computers will be different because of this. And for our AI infra, we will focus on the GPU, I mean the hardware layer, we will focus on the GPU's design or usage. And in the middle layer, we will focus on the development of the large models and the the data pipelines and all of these to support the AI applications. Next slide. So in this slide, I briefly we briefly talk about the machine learning life cycles. Actually, that's I think most companies the workflow they are the same. So first of all, we should design the business metrics which to define whether this model is useful or is success. And then we need to collect the data to train or support these models. And then we implement the code to train the models. There's the pipeline to read the data, train the model in according to our business metrics. And then after our model is training, we will serve the model, which is inference. So inference is also very important because in the long run, maybe the one training model will be used for a very long time. Like if you remember the ChatGPT or GPT-3 or 4, so after it get trained, it will be used for a long time, which will consume a lot of resources like GPU or other resources in the inference stage. So so mostly, if we want to design an AI applications, we will go through this different stage. And in the big companies, each of these stage will be responsible by different teams. Maybe even one stage will be responsible by multiple teams. For example, for the data, we have the storage layer, the computation layer, the analyze layer, like that. So we will have many people working on different domains here. So all of these domains, they are kind of related to the AI infrastructures we mentioned here. Yeah. Okay, next slide. So then I will talk about the three aspects that I think very important for the AI infrastructure. So the first one is the data. So why data is important is I think if you major in the machine learning courses, you will know that. So if we have valuable data, it's easy for us to build a very valuable models. So the data's quality is very important for us. So and also as we have more and more data, how to store the data, how to process the data is also very challenging. And as you can see, after ChatGPT becomes famous, there's another term that related to the database also become famous, which is vector DB, right? So it is used in most AI applications. So there are many new things that become, I mean, vector DB is not new, but it become famous again in the AI industry. So if we want to manage this data very well, we need to have a new kind of schema or new kind of database to manage all of these data. So which means there's very new many new challenges for us to manage the data in the daily work. So And another thing I think many computer scientists, they also care about is um, explainability of the data or the models. As you can see, most people think you know, we know that AI is good, but we don't know why it's good. So many of the reason is because we can't understand the data very well. So how to manage the data, how to organize the data here can also help us to improve the explainability of the AI models. Next slide, please. uh, the second thing I want to mention is about the pipeline of the whole AI infra systems. I think that's also one of the main difference with what we learned from the textbook or at school. So during the course at school, maybe most of you will train a small model using a small portion of data. And this whole system may be just in one repo with one server to do all of them. But in uh, in enterprise domain, many of these things they will be split into different systems. It is a very complicated distributed system. In this in this slides, you can see that so first of all, if a user when they use any device like an iPhone or a MacBook, so they will send some requests to the servers, and from our servers we will collect many behaviors and send to some process pipelines like the Spark to process all of the requests and store that into the database just now we mentioned. And after we store all the data, we will in the backend we have a pipeline to train all these data and then update our models based on the user's behaviors. So most of these actions they are happen in the background with you know, the user they don't know what happens out there. So it's totally happened offline. And then if user issue a request, like you ask a question in the ChatGPT, so you send a request to the servers, and the inference server they will come into play and trying to use the data, the model we just trained to generate the content for the users. So as you can see in enterprise level, so it's a very complicated distributed system. So in every aspect, like just now we mentioned about the storage, right? So you can think about how should we store this large amount of data in the company, and also about the training. So we can build very large clusters to train the data and the model to generate valuable results. And also for the inference, so because the user is much more than I mean, we need to serve many requests every day. So the inference cluster is also much bigger, and they will consume a lot of resources in the server set. How should we manage these systems? They are very critical, and it's also the daily work of the AI, I mean the machine learning engineers in TikTok. So that's the whole development plan or the architecture of the AI infra. It's a very general architecture. Yeah. So next slide. Um, yeah, the third thing I want to talk about is just now we talked about the distributed systems. So, but in another way, we also care about the performance of a single instance. So how to use better use the single servers, especially how to use the GPU efficiently. Also, very important part of work in the engineers imbalance. So this is a diagram of the TensorFlow architecture. As you can see, except for they support different user-facing APIs like the TensorFlow JS or the other many language bindings. So we have a important part is about the distribution strategy, especially how should we dispatch our workloads to the CPU or GPU or TPU. So to better use these hardwares to train our models, and how should these devices to communicate with each other? It's so it will involve many things we learned at school, like the compilers or the optimization or the memory management or the network connections. So they are all related to the optimization of these frameworks. And also on top of that, we have many libraries like the feature column or many data management features to help the the algorithms to better implement their algorithms for them to easy to write the code, because not everyone understand how the GPU or works or how they communicate. We need to provide a very high level API for them to use, so that they can just focus on the model training or the algorithms part. And we as an infrastructure engineers, we handle all the remaining parts of this framework. So with this part, we optimize the single instance. We also manage a distributed system to support the large portion of data and the heavy model training process. So with all of this, we can support the development of the large models in TikTok. Next slides. So yeah, so just now we talked about the brief history of AI, and then we talk about the main development flow of AI models and how we manage the distributed systems in the AI infras, and also what we need to do to optimize the TensorFlow or other AI frameworks. So then because this is about the TechJams, so I will share with you some ideas about some of the projects that you might interested to working on. So next slides. So in these slides, you can see in the AI infra stack, you can working on different modules. So I think for you guys, you can choose anything that you interested. Like if you are interested in the inference, then you can build some inference service that can load model maybe from the Llama or Hugging Face, like because there are many open source models there we can use. So you can build some inference engines that can use these models. If you are interested in the model training, then you can think about how should we optimize the performance of the model training. So maybe for you, you can trying to find some open source project and trying to contribute to one of the project. Then so because our TechJam, I think mostly we want you to show your coding skills and to show your interest and your ability in these domains. So you need to try to contribute to one of these domains, whether it's open source or closed source. But anyway, we need to see that your coding ability, in these TechJams. And also, I mean, if you are interested in about the database, like the data storage, you can also contribute to this domain. So especially if it is related to the AI usage of the database. So that's about the directions that you can contribute. And there are many companies listed in here. So you can try to do some research to see how what these companies are doing, and you can try to start small, just trying to start from a small ideas, or you can discuss with your classmates, trying to build some projects that solve one problem very well, so that you can showcase to us. So you can also discuss in your with your mentor or professor about your research topic. But mostly, we hope it can be related to the AI infrastructure. Not only not only about the models development, because the infrastructure side, there are many challenges we can see and we want to solve. So yeah, I think that's all about my sharing today. So I will hand back to AB.